Is this on? Okay, great. I'm Addison Snell with Intersect360 Research. I do know that I'm the last one before lunch, but I really enjoyed the panel conversation we were having yesterday on exascale and other topics, and wanted to come back around to a lot of those things. So Intersect360 Research, we're an industry analyst firm that focuses on high-performance computing and hyperscale kinds of topics. I mentioned briefly yesterday, we now have a 10-year history doing this in the industry. We started as Tabor Research in the beginning of 2007. So we're now 10 years old in this space, which leaves me a bit wondering where that decade went. But the last HPC Advisory Council meeting, we did a bit of a retrospective on the last 10 years and then 10-year look ahead. I published an article on that topic in HPCwire in honor of the fact that we started as Tabor Research and was part of that same Tabor Communications organization. Things have certainly changed over the last 10 years. One of them is the emergence of hyperscale. And I'll comment on that in my presentation today, but that's really a major dynamic that's going on this year. I've been doing weekly podcasts in one form or another for nearly 8 years now. The current incarnation is called This Week in HPC. It's distributed in partnership with top500.org. You can find that on iTunes, Stitcher, SoundCloud, our website, follow at This Week in HPC, all kinds of things. So if you don't get enough of me talking at things like this, there's a podcast comes out every week together with me together with Michael Feldman, who's at top500.org. We have many media partnerships, including insideHPC, Next Platform, HPCwire, and of course we're sponsors of the HPC Advisory Council. I think we've presented at every one of these around the world for the last several years, with the exception of the ones in China. And that is nothing against China. I would love to go back to China and attend one of those. It's just that the HPC Advisory Council meetings in China have been like 2 or 3 weeks before the supercomputing conference, and it's been a bad time for us to travel there. So we'll look forward to continuing more with the HPC Advisory Council, not only at the meetings, but as an ongoing community. I wanted to tailor my presentation to some of the things that we talked about yesterday. I think the biggest topic that came up in many of the presentations and also in the panel was this idea of architecture specialization being a major trend going on in the industry. Also heard a lot of questions on HPC and cloud, so I'll touch on that, although it's been a perennial topic over the last couple of years. HPC versus hyperscale and what that has to do with machine learning and AI. That mixed in with just salt from other presentations that are current. Okay, starting with architectural specialization. Bit of an eye chart, but this is the chart that I said yesterday I would consider whether or not I wanted to show. This came out of a special study that we published almost a year ago now. So data rots quickly in this industry, but the question at hand here had to concerned what were end users' forward-looking views of the different processor architectures available, listing all of these as available options that you might be realistically considering for HPC. Now, this is one of these, how do you feel on a scale of 1 to 5, right? So it's a favorable, unfavorable. That makes 3 your midpoint because there's no 0, so it's not 2.5, right? 3 is the midpoint between 1 and 5. And things that go out to the right of this line are favorable, things that are out to the left are unfavorable. Don't cut it too fine, right? And be like, well, this is favorable and that's unfavorable, so that's better than that. Really, anything kind of between 2.5 and 3.5 is mostly neutral, okay? And then look at what are the things that are favorable. Well, in people like Xeon, that was the biggest thing that was out there. People like GPUs, that's kind of right out there. And then coming in behind that is this idea of Xeon Phi as a standalone processor, not as a co-processor, but as a standalone processor, which was how Intel started to market it kind of both ways. The initial incarnation was more of a co-processor idea. Well, no, the initial incarnation was Larrabee. It was a graphics thing, but I mean, it became Xeon Phi, which is now a standalone processor. And then out on the negative side, Spark, DSPs, Quantum, maybe Vector has started leaning out there. And then there's a lot of stuff in the middle, right? And all that stuff in the middle falls into what we were talking about yesterday as being in this, gosh, wait and see, kind of evaluate sort of concept. Here are a few of the details on some of those that we talked about. Here's power and OpenPOWER, where the basic question is, are you going to definitely use, over the next few years, are you going to definitely use it? Are you going to evaluate it? Are you not going to evaluate it? So, all right, the cynic would say that about half the market has no plans to use or evaluate power. But the other side of the way to look at it is that half the market is going to definitely use or evaluate power processors for their HPC environment. So what's the market opportunity for power here? If you're starting from 13% of respondents say, I'm definitely going to have some somewhere, which isn't to say that's 13% market share, right? Because people have multiple architectures. Repeating what I said yesterday, 88% of respondents said they would have multiple architectures over the next couple years. So maybe, some of these are small testing systems. Maybe it's a primary system. That doesn't equal 13% share because ultimately this stuff adds up to way more than 100. But you're going to start from 13% of end users say they'll definitely have some power somewhere, and another 40% are going to evaluate it. That adds up to a pretty good market opportunity for IBM to make a push in this market with power. So what about ARM? ARM is pretty much the same thing. The same wedge saying, well, I'm definitely going to have it, and even more saying they would evaluate it. These are just a couple of charts to point to the fact that this is completely up in the air right now, that there's a lot of evaluation, and that's to say nothing of Xeons and GPUs, which are the bigger things in there. And we have charts like this for every other thing that was on there, for quantum, for vector, for DSPs, for FPGAs. We can tell you, what are the ratios of people evaluating. But between power and ARM, those are some of the more interesting alternate non-x86 alternatives that are out there, and they're definitely going to be getting evaluation this year, next year, into the future, and then we'll see how well these things run. Yeah, Gilad. Go for it.
Do you do correlation between people that says that they can definitely use power and definitely use ARM? The same people?
The question is there correlation between people who said definitely this and definitely that? And who's not going to evaluate. Yes, we have those correlations. We can also do segmentations by economic sector, by supercomputer down to entry level. It gets a lot different. A small commercial customer is less likely to be testing out a lot of different alternatives than a large public sector research facility, which is going to test everything, right? So that's kind of the cheap and easy answer, but down in the level of details, we can do all those segmentations. So then where does that leave Intel versus some of the competition in some of these big categories? And one of them that comes up is accelerators. Now, let me point out the footnote here, because we're cheating a little bit with the term accelerator here and really need to start to change our terminology here, because it's no longer strictly accurate to call Intel Xeon Phi an accelerator. It's a standalone processor, and yet for the purposes of this study, we were acknowledging the fact that the majority of end users still think of it like it's an accelerator because it's a many-core component. So this is now from a different study. This is from our site census study, just looking at the installed base, but including Xeon Phi in this concept of many-core accelerators. NVIDIA is still dominant, whether you look at it by share of systems, by share of total accelerators out there. So Intel with Xeon Phi, or anything, FPGAs, everything else, is coming from behind because NVIDIA's been out there for 5 years with CUDA. And there's a long grassroots effort with CUDA to get applications ported to those many-core components. On the other hand, it's always hard to bet against Intel. They're in there with an x86-based model. They're going to say it's all the same x86 tools. I would have gone for years saying you can't bet against Intel, you can't bet against Intel, you can't bet against Intel. But where they are now, you can absolutely bet against Intel with this, just because they've given NVIDIA so much of a head start. That's a big head start to come from behind on. I am not in this presentation going to go start picking winners. I'm just highlighting where the current market dynamics are, and with our clients, we absolutely engage on these topics. So that's where they are now. The big challenge is coming from behind on the software side, but Xeon Phi with all x86 and Intel tools, that's a formidable thing. Then you can start looking at the networking side too, because they're going to be coming out with OmniPath. Now, OmniPath is going to go toe-to-toe with Mellanox, but here's Mellanox InfiniBand, which is the dominant system interconnect supplier, and Intel is just showing up with a couple of systems, whether they're QLogic things that Intel brought in, or you were starting to get a couple of OmniPath systems and storage systems. Really, this year is going to be when we start measuring in our next site census survey what kind of uptake OmniPath starts to get. They have an advantage with being incumbent with the x86 architecture, but they're at a disadvantage coming from behind. We also measured the forward-looking expectations, like I showed you on that first chart, the bar charts, with Interconnects. I did not put the details on that into that chart, but people have better forward-looking impressions of InfiniBand than they do of OmniPath. Will that change over a year, over 2 years? Yeah, it could change. But Intel, again, for all the advantage they have being the incumbent system architecture, is coming from behind also on Interconnects. Cisco's in here, by the way, just because Cisco sells interconnects to everybody. I mean, they're the LAN supplier. They're a huge Ethernet supplier, despite the fact that Cisco has absolutely no intentional strategy around HPC whatsoever. There are a few people in there who know about HPC, but if I ever try to talk to them, their analyst relations people come down on me and smack me and say, we don't do HPC, go away, no one's allowed to talk to you. It's kind of funny sometimes, because then here they are, like, actually, you kind of do HPC if you want to look at this report, but they don't care. Next chart, before I put it up, I'm glad I didn't hit forward yet. Just for fun, I wanted to put up one of the applications charts on what some of the top applications are, because we don't show that one very often, and it highlights how wide open or how diverse the software space is in HPC. Anyone care to guess, just shouting out loud, what some of the top 5 reported open source applications are in HPC? Top 5 open source applications, not including middleware or developer tools, but end user applications. What do you think's in the top 5? OpenPOWER is not in the top 5, but it is fast growing. Anyone else? Amber's a good guess, but no, Gaussian is in there. How about the top 5 ISV applications, commercial licensed applications? Fluent is definitely there. What else do people say? ANSYS is there. So here we go. Here are the top 5 open source applications reported: Gaussian, GROMACS, VASP, NAND, and WARF. But even among open source, those top 5 don't even get you to a third. And it starts going into a long tail rapidly after that, a long tail. Top 5 ISV applications, not surprising that these are going to be on the engineering side, a lot in manufacturing. So you get the top fluids code, which is Fluent, and then the next 3 are structures codes with Abacus, ANSYS, and Dyna. People know what IDL is? It's interactive data language, which at first you're tempted to categorize as middleware, but then you look at what it is. It's analytics software. It's the top reported analytics code that shows up in our survey. And at 2% of all ISV mentions becomes the 5th most common. So everything else after that is less than 2% just out of ISV codes. If you shuffle these together, Gaussian and Fluent wind up being close. Gaussian is still number 1 just in terms of the overall total mentions, but that's because academic returns heavy in the survey. Fluent is really overall, if you blend it, the most common application out there, but declining because OpenPOWER is growing. So there's a lot of dynamics out there. This is when people say, well, what's the killer app I need for HPC, Mr. Analyst? Tell me the app that I need to go dominant. Well, I can tell you what app will get you, 4% of the market. Is that the killer app? There you go. Well, just tell me the top 5 applications that'll get me 80% of the market. It's not like that, okay? The top 10 applications together don't get you to 30% of the market. We have a database with thousands of records in it of all kinds of obscure stuff. And this doesn't even include yet all the in-house applications, which aren't worth building a chart over because the number one mention is going to have an N value of 1, right? They're all in-house, and we just have hundreds of them. Yeah, Christian?
But for big data, for high-performance big data, this might change, right? Because then you have like Hadoop and Kafka and stuff like that, which is more open source, right?
Yeah, for high-performance big data, Hadoop, when we did custom studies on big data, now this goes back to 2014, would have been the last time we published on this. Hadoop was mentioned by 17% of respondents who said they had big data applications, which meant your huge killer app for big data was still less than 20% of big data respondents, right? Over 60%, about 60% in that time said they were just doing in-house applications and algorithms. So more than half of your brownie pan was unfused brownie batter atoms that couldn't, you had to spoon them out and eat them like cereal instead of holding a brownie, right? So that was the big opportunity that people missed. Everyone was running to Hadoop or Spark. The much bigger market opportunity would have been to say, I can help you scale whatever you're doing in-house. Right? And just no one was on that page, and it was the biggest market opportunity. Yeah.
Is there a way to visualize this in terms of categories like machine learning, something to do with, say, engineering applications and that kind of?
The question is, can we segment it by type of, yes, we can segment this by vertical market. We can segment it by type of application. Now, you mentioned machine learning. That's going to be part of our Hyperscale service. This is HPC here, but the answer is yes, we can do it for all the categories of HPC applications. Our applications report does that specifically. How close is Amber to the top? Pretty close. Amber is like right in here somewhere. I'd have to go to my own report and look, but I think it's in the top 10. Okay, so I just put that one up for fun, even though it didn't come up yesterday. Cloud did come up yesterday, and I'm an analyst, so I have to put up a forecast chart. Now, here we are at the start of 2017, but we have not finished the 2016 numbers yet. That usually happens around April because we have to wait for vendors to report, and then there's a lot of work to be done. Chris Willard, our Chief Research Officer, is in the middle of that now. So maybe in Lugano we'll have something to present on that, or more likely the one after that. So 2015 here is our last actual. Everything left of this point is actuals, right of this point is forecasts. Everyone with me on that? So we're looking at 2016, forecasting it coming into being about a $30 billion market. We might come in just shy of this forecast. We have not had our all-day forecasting meeting yet where we go gloves off and steel cage match and fight about the new forecast and the new market model. But if anything, one thing that we hadn't forecast was the ongoing slowness in the energy market. We would have thought it would have picked up faster than it did. So energy is going to be a little soft, and we have to talk about whether government was softer than we forecast it. But if I had to bet, I would bet down very slightly from this number rather than up very slightly from this number. Forecast, the biggest change in the forecast we're going to have to talk about is the Trump administration and what effect that will have on the U.S. market, which is nearly half of the overall HPC market. It's about 45% or so is U.S.-based. Just my initial thoughts on the Trump administration relative to the previous administration is we can guess that, he hasn't done anything yet, right? He's barely in office. But if you just go by patterns and how we'd analyze it, you'd think he's going to be softer. I would think he's going to be softer on publicly funded national science research. We already talked about the DOE in the panel yesterday. That could spill over to things like NSF and NIH. Other federally funded government research could be down, perhaps substantially down. Military, government defense, homeland security is anybody's guess right now. It's really difficult to predict how spending there is going to go. He seems to lean a little more hawkish than dovish, but it's hard to predict how that will translate into high-performance computing spending for the military or homeland security. But then on the commercial side, Some of the biggest HPC vertical markets are things that have come up in his campaign rhetoric. He wants more investment in manufacturing, more investment in energy, deregulation in finance, deregulation in pharmaceuticals, all of which can lead to increased spending in those vertical markets. Now, to what extent the one effect offsets the other, we haven't done the whole exercise yet, but it's going to be things pointing in those directions. The real reason I put this chart up is because of cloud, which kept coming up. How much HPC is in the cloud? Well, here it is. It's that orange slice right here. HPC long-term has been pretty allergic to cloud for a multitude of reasons, and people can talk about security or data movement or the other barriers. The better thinking around that is to look at the drivers or lack thereof, because I think, especially as cloud really took off in this era, I think there was this natural presumption, this bias, this prejudice that why wouldn't you go to cloud? Cloud's awesome. It must be cheaper to do in the cloud, right? And what you find is that most HPC users don't actually think it's going to be cheaper to shut down my HPC system, move it all onto Amazon or Google or what have you, pay them to do it the way I wanted to do it and give them a profit, and that it's cheaper, right? It actually, in most cases, does not get cheaper unless you really have a variable workload where you're very spiky. You need big increases in performance for a relatively short period of time. Then the cloud model starts making sense. It has been getting easier, and 2014 we did see an elbow where it was flat, 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 and then wow, here it goes to huge exponential growth. Starting from here, we're in double-digit growth mode through the rest of the forecast period, which will bring it to about 3.2% of the market by the end of the forecast period, which is nearly double what it was out here, right? Which is big, enormous growth. It doesn't take over the market that fast. It's not going to be 20% of the market. It's not going to be 10% of the market by the end of 10 years from now. It'll be less than 10% of the market. Yes?
Are the software dollars just expenses for licensing and rental costs of software, or does that include development costs in-house or contracted FTEs, for instance?
Okay, in case people didn't hear the question, what's in the software? It is money that gets paid for software. It is not in-house development, which is not part of this chart. If you're paying, we could separately map onto this other internally budgeted items like personnel, power consumption, things like that. But because that's not product or services spending, it doesn't show up in what an analyst would typically call a market size. But if you wanted to see what would be, maybe you call it a total budget model that includes things like personnel and power consumption, we can put that out there also. It adds about half to the overall spending. So what I would pay a software developer internally is not shown here. If I buy software, it is shown here. But this includes all categories of software in that purple bar. So it includes not just end-user application software, but things like developer tools, middleware, operating system licenses, storage system licenses is actually a pretty big category if you're paying for file systems. It can even in some cases, although this is not common, this violates our internal spending rule a little bit. There is a provision for transfer costs where my HPC budget buys software from a different division of the same company that developed it. This is actually a model that occurs in pharmaceutical companies sometimes. You have a software development group, and then they sell the software like it's a business to the HPC group. So from a HPC budget standpoint, it looks like external spending, but the money never left the company. If you're worried about the overall effect of that on the total market, don't. It's pretty small, but I'm just mentioning it's in there. Yes?
When you mentioned the elasticity of the cloud, in terms of the context of HPC, is there a particular workflow that's accommodating that we're not adequately capturing within the budgeting of HPC traditional resources?
Is there a particular workflow that's going to cloud? You know, the most common things are public sector research because they don't have the licensing problems, they don't have the intellectual property problems. The biggest user of public cloud is actually academia. If you go into the commercial world, the vertical market that does it the most is the pharma industry, which I was just talking about. And it's the only industry where we've had a reasonable number of end user surveys coming back telling us they intend to spend less on their capital by up to about 20% at the high end and move the balance to cloud. But that's actually consistent with this model where you get one vertical market where some users somewhere tell you they'll reduce their spending by as much as 20%. By the time you net that out on average across the whole industry, these numbers are right. Yes?
Addison, do you see that companies are more willing to just brute force it on cloud and just, versus spend more development dollars and optimize the code so it's more energy efficient and, it's more performant, right? So if you get like 30-40% efficiency on the nodes, then you're not, you're using way more nodes than you need. So do you see the actual companies that have the problems are more willing to pay development dollars in-house in their internal, data center, or they'll just brute force it because they're spending money either way, right?
That question's asked at a level of specificity that's dangerous to generalize the intent of the person moving to cloud with how diverse the HPC industry is. I think to look at any movement to cloud and say, well, this person's doing it this way, therefore everyone's doing it that way. I think there are really individualized motivations around this. I would not draw that conclusion. I would advise my clients when they see cloud getting incorporated to just ask their end user why they're doing it and what the motivation is, and then listen rather than presume. Okay. Hyperscale market. I do want to touch on this because it kept coming up. I mentioned that we started counting this in 2007 as ultra-scale internet. 2007 was the same year, not only we were founded, but I mentioned in the panel yesterday, Google acquired a stream computing company called PeakStream that we had been tracking as an HPC player. Steve Scott left Cray and went to Google. He then went round trip. But we knew that there was HPC going on at these big places, and we called it ultra-scale internet and identified it as a segment underneath high-performance business computing. But really in 2014, we started deciding this was really not only taking off, but the trends there were different than the trends were in HPC. And in 2015, what we by then started calling hyperscale, the ultra-scale term didn't win out. 8 years later, hyperscale was what it was called. We realized it was a distinct market, a proximity market to HPC that's not the same as HPC. And Chris Willard began the very long process, an arduous process of scrubbing ultra-scale internet out of all of our back models and setting it up as a separate forecast model going forward. We have defined a methodology around that. We published our first definitions and methodology report in April 2016, and we're now doing market sizing and advisory services around hyperscale. If we try to get the definition of hyperscale down to one tweet, it starts looking like this. Not to be pedantic about it, but I'm an analyst, so it's actually my job to be pedantic. We feel like if we're going to start counting something, we need to be specific about what it is we're counting. We've been through this with big data and other trends. We don't want to come out with a forecast and say, well, the big data market is umpty-ump $1 billion and growing at 11.3% when you haven't yet put out a document that says what it is you're counting. Like, what is one big data and how much does it cost, right? Until you've done that, to say how big the market is kind of pointless. So here we're talking about the infrastructure for arbitrarily scalable web-facing application infrastructure. Every word there is carefully chosen. Arbitrarily scalable is an important concept. And it means the same thing it means in HPC in this case, which is that there's not a theoretical maximum size of how big the problem gets. Your weather simulation you can keep doing by refining the mesh, higher degrees of fidelity, more degrees of freedom in the model. You're not going to get to a point anytime in the next 100 years where you say you're accurately forecasting weather and climate down to the atomic level and rolling it forward. You can keep making it more and more accurate over time, and you're not going to get to a point where you say you're done. Similarly, not only just in the top tier ones like a Google or an Amazon or Facebook, you're not saying, well, there's other than to what extent it's capped by the population of the universe and how many accounts someone can have. It really scales along with the internet, right? There's not a maximum size to Google and how much information it's going to have. There's not a maximum size to Amazon and how many products it can sell, or Comcast and how many videos it can stream. It is arbitrarily scalable along with the internet, even if you go down to a tier 3 hyperscale company, someone we would say barely makes the cut, like a Wikipedia. Okay, Wikipedia, they're not spending $1 billion a year on IT. They're spending more like $1 million a year on IT. So they just get over that hurdle. But there's not like a theoretical maximum size to Wikipedia, right? It keeps getting bigger as long as people keep putting more information onto it. And it has to be distinct application infrastructure, which is again in common with HPC and separates it from general enterprise computing. You can walk into a single organization like a PayPal and start pointing to segments of infrastructure. This is the stuff that does high-performance computing applications. This is the stuff that's web-facing hyperscale infrastructure. And then this is the stuff that runs our business, our internal payroll database or accounting systems or things like that. They're 3 distinct piles of infrastructure. Big data, by the way, is not like that. The vast majority of people doing big data applications are doing it mixed into their general enterprise infrastructure. It is not a separate pile of infrastructure to do big data. So to call something a big data market is, in some sense, a malformed concept because you can't point to a separate pile of stuff that's being bought. This is how the tiers break out. Yeah.
But isn't like LHC and this square kilometer array thing, isn't it more HPC, big data than HPC? I mean, you have a lot of information that spills out and you are not coming up with a model and then you try to...
There are big data focused installations. There are some. But 90+% of people doing big data are doing it mixed in with their general enterprise infrastructure. It is not a well-formed set. Anyone who says they're counting the big data market, mostly what they're, or high performance data and analytics or something, mostly what they're doing is apportioning systems that were already there. And the way you know this is true, by the way, is if the big data market is this new $30 billion market, where did it come from? Because overall enterprise IT stayed flat, right? There was no new money anywhere, and yet there's this whole new market. So it's kind of case in point. This is how we're tiering the big data market right now. All of this is draft, by the way. We have not yet published it, so consider yourselves lucky. But we're right now looking at 3 tiers. The top tier are these top 8 companies that everybody talks about. But interesting footnote, they're not necessarily 100% the same 8 you think they are. And I'll just leave that hanging out there as a thought question for everybody else. But we do count 8 organizations that are spending over $1 billion per year with a B on IT infrastructure. Over $1 billion a year. We count 3 that are spending over $2 billion a year, and 1 that is spending over $3 billion a year, and that 1 is also spending over $4 billion a year, and closing in on 5. There is a lot of money in these tier 1s, and like in the high-performance computing market, where you have a supercomputing tier, and their investments in things like software and middleware and systems have influence through the rest of the industry, so too do you have this influence of this top tier and what goes on with things like Open Compute Project and OpenStack and Scorpio starts percolating down through the rest of the hyperscale market. Now below that, we think at the one, now also a big difference is about an order of magnitude difference between what a top tier 1 hyperscale spends and a tier 1 supercomputer center spends. You go from hundreds of millions at a supercomputer center up to billions for a hyperscale center. They're 10 times bigger. This second tier of people spending over 100 million a year has about 40 companies in it. That's going to be, I mentioned Comcast. They're a great example of someone who's not spending over $1 billion a year, but they are having a lot of influence in this market. You start getting some of the biggest online gaming companies out there. You want to start getting alarmed, go start looking at, dig up the online gaming companies and how big some of those are. There is also at least 1 pornography company in here. Those scale along with the internet too, and they serve out an awful lot of content. Tier 3, not every company spending over $1 million a year on IT is going to automatically be a hyperscale organization. The question is, what are they spending it on? Large enterprise can fall into this, but unless they're spending it on a web-facing application infrastructure, they're not going to be counted as a hyperscale. I want to move this along. So it's about a $35 billion market, which makes it slightly larger than the HPC market overall, but concentrated into fewer users. We're only talking on the order of hundreds of users overall. Deep learning is part of the hyperscale market, as I was saying yesterday. Deep learning is not an application unto itself. It is an approach. We are open to the idea of you can use deep learning for HPC applications, but we have not yet seen that in a huge way that it's moving the needle in the HPC market. Almost all of the real spending on deep learning and machine learning, artificial intelligence, is being driven out of the large hyperscale companies right now, mostly the tier 1s and some of the biggest tier 2s. Almost all of the tier 1s have some sort of footprint in it. Google does, Microsoft does, Facebook does, Amazon does, Apple does, Baidu are all leaders in this space. The applications are similar to but distinct from HPC for some of the reasons that we talked about yesterday. There's an emphasis on lower precision. There's a high degree of affinity to cloud and cloud architectures, which is polar opposite from HPC. Where 95+% of HPC was not in the cloud, 95+% of machine learning, deep learning is in the cloud. It's almost all cloud, at least right now. And there's also the question I highlighted on the panel and won't go into again, but long term, how scalable is it? Does it remain an HPC-like application over 20 years is an interesting thought question. We have looked at the size of this market within hyperscale, and we've done this a lot of different ways. The point is that out of that $35 billion, currently the range is $2 to $2.5 billion for 2016. Is directly going to things like deep learning, machine learning, where you can see a differentiated infrastructure around that. That's about 6.5% of the hyperscale market overall, and we will publish a real figure on this very soon. A big thing here, though, is that we expect the growth rate on this to be very high for the next 2 years. This could roughly double year on year for the next 2 years, reaching close to $10 billion by the end of 2018. But after that, somewhere soon after that, it should plateau. You will not keep a 100% exponential growth rate for years and years and years. Eventually, this starts tapering off and could even not only plateau, but retract by the end of a 5-year period where it goes into a slight negative growth mode. Next 10 years, people talked about, and then this will be my last slide. And I repeated this exact slide at the last HPC Advisory Council, but it's important, so I'll do it again. First and foremost, the HPC market, forgetting about hyperscale, forgetting about deep learning, forgetting about big data, and every other hot buzzword that comes through this market year after year after year, where people want to seize on to what the hot new thing is, because 4% growth isn't enough for people. The fundamental drivers of traditional HPC are strong and will remain strong forever because of what I was saying before, that we're not at the end of science yet. And until you reach the end of science and engineering and there's nothing more to be discovered or designed, there's going to be a need for high-performance computing into the future. This market will still be here with a solid plodding growth rate 100 years from now. It is a stable long-term market. We are going back to this era of specialization with custom architectures reemerging in the market. There is room for all kinds of weird stuff in the market right now. You're going to see companies with specialized architectures again, carving out niches for themselves. We're going to go back to that era of specialization away from the Beowulf model. Public cloud utility computing is going to remain well below 10% of the HPC market through the next 10 years. It might even remain below 5, but I'll certainly say well below 10. I mentioned object storage yesterday as by the end of this 10-year period, it's going to start to take off. I think that's going to be an important trend, and if you're looking for an intriguing technology to start to make bets on, I would start looking at object storage as a potential for for growing. Now, if you really want the breakout opportunities for HPC-associated technologies, they're going to be in the hyperscale market. That is a huge plus-up opportunity for things like many core architectures, as long as they're low precision, for high-performance interconnects, for different types of storage. Those things are going to take off. It's going to be driven by AI. Also have not talked about virtual reality, augmented reality. That is going to take off. A lot of it's going to be lower end, but will be driven by some larger back-end computation. Those are going to be huge trends. Hyperscale is going to really have a huge influence on this market and IT in general over the next 10 years. Okay, that's my talk. I took questions throughout and ended up right on my allotted time. Do you want me to take more questions now or let people eat? That's a loaded question. I put it on you, Sydney. Do people want me to take more questions, or do you want a sandwich? All right, thanks very much, everybody.